What is Spark SQL? Spark SQL is a library to process Spark data objects using SQL statements. Using SQL statement. In previous section, we seen Spark core. There we used RDD programming. RDD programming to process the data. RDD programming to process the data, right? But today we are going to learn SQL programming to process Spark data objects. So to represent data in structure form, we go for Spark SQL. Spark SQL follows syntaxes of MySQL, similar to MySQL. Okay, Spark SQL follows similar syntax of MySQL syntax. In Spark core, to store objects in Spark core, what we need Spark context, right? To store first in Spark application, to create the Spark application, we need Spark context, right? So here in Spark SQL, to deal with the Spark SQL, we need to create SQL context or Hive context. We need to create SQL context or Hive context. SQL context or Hive context. In Spark 1.6 onwards, they introduced one more Spark 2. They introduced another context. We'll discuss later. Okay, SQL context or Hive context. Okay, in Spark 2, they introduced Spark session. In Spark 2, they introduced Spark session. Spark session contain SQL Spark context, SQL context, Hive context. Instead of creating separate context, you can directly create a Spark session. That Spark session contain all these contexts inbuilt. So no need to create individual context. Here Spark session has all the contexts. Okay. In Spark core, what is the data storage object, Ravi? Ravi, in Spark core, what is the data storage object? RDD. Yes, right. RDDs are data storage objects. In Spark SQL, the data storage objects are data frames, data sets, and tables. Data frames, data sets, and tables. To write RDD programming, we need to import which package, Rameshan? To write RDD programming, what is the package we need to import? Only Spark underscore. Then tell me complete syntax, Ramesh. Oh, great. So Spark core is completed. You forget Spark core. So today we are discussing SQL, right? So import org.apache. Import org.apache.spark underscore. Just only you forgot org.apache. Okay, same as to so for that import package, for that package we need to add which jar file. So to use that package we need to download one jar file, or we need to add dependency. What is the dependency we need to add, or we need to download jar file? Spark core jar file is mandatory, right? So to write Spark core programming, Spark core programming, we need to use class called SQL context. SQL context and SQL config RDD related programming classes presented in org.apache.spark.underscore. So for all this, we need to add Spark core dependency. Yes or no? Same as, so to create a Spark SQL, to create or to write Spark SQL programming, to write Spark SQL programming. So without creating without creating Spark context object, we cannot write any Spark application, right? So we need to import that package org.apache.spark.underscore one, and we need to add a Spark code dependency. So to write a Spark SQL also we require those Spark code dependency. We need to import that package. Next one, SQL context and Hive context is available in package called org.apache.spark.sql.underscore. Okay, so this package is presented in Spark SQL jar file. So we need to import two jar files. One is Spark core jar file and another one is Spark SQL jar file. So to write Spark SQL programming, we need two dependencies, Spark core and Spark SQL. Okay, so let's create a project. Let's go open our IntelliJ IDEA. Okay, it is open. Let's create a project. New project. I'm creating Spark SQL project. So Scala SBT. Click on next. Create new project. So under workspace, create new folder called Spark SQL. Click OK. Then click OK. Here select Scala version 2.11.12. Okay. Then click on finish. Yes, I want to open in this window. Expand this one. Let's wait. It is creating project structure. Okay, project structure is created. Let's click on SBT. Click on import project. Parallelly search Spark Core and Spark SQL. Spark dependency. Go to this location. Go to Spark org.spark. We need Spark Core and we need Spark SQL. So click on 2.3.1. Add this dependency. Let's wait. We need this dependency as well as we need this Spark SQL dependency. Add these two dependencies. Go to SBT directory. Add this one. Okay. Refresh here. It will import the packages. Create one class. So it's importing project model. Let's wait to import project model. Once it is completed, let's create a new Scala class. Spark SQL, Spark SQL app1. So change this one to object. Click OK. Then write def space main. I'm writing just syntax. Okay. Next, go to its applying changes. Let's wait to apply. Yep, successful. Let's go to SBT. Then type console. Yep. So SBT console is started. Now tell me, we need to import first. Import org dot apache dot spark dot underscore. We need to import this package. Next one, import org dot apache dot spark dot sql dot underscore. We need to import this package. Next one, create val s equal to new spark context, new spark context, new spark conf dot set spark dot master comma. Next one, master name local. Next, dot set spark dot app dot name comma spark sql app spark sql app. So it is going to create what? Spark context object. Yep. So Spark context object is created. Let's set log level. Log level. Set log level. Warning. Log level. Warning. Okay. We set log level equal to warning. So we set log level equal to warning. Okay. Next one. Create either Spark context. Sorry. SQL context or create SQL context or Hive context to deal with Spark SQL. Okay. So create SQL context or Hive context. SQL context or Hive context. So I am creating val SQL C equal to new SQL context and pass Spark context object. Pass Spark context object. Okay. So to create SQL context object, we need to pass Spark context object. So without a Spark context object, there is no Spark application. Whether we may use directly or indirectly, Spark context is important. Next one, what I'm doing, we need to create data frame or data set or table to store data. In Spark core, we use RDD to store data objects, data, right? In Spark SQL, we use data frames or data sets or tables to store SQL objects. Okay. So here to create these objects, SQL context or a Hive context or Spark session, we need to import above the packages we imported. And data frame and data sets are tabular representation of data. Both data frame and data set both are for tabular representation of data. SQL context does not support Hive integration. That's why we have Hive context separate. Spark session supports Hive integration. By default, it contains Hive integration. So what is the difference between SQL statements from Hive and from Spark? What is the difference between SQL statements from Hive and from Spark? So we write the same SQL statements in Hive also. We use the same SQL statement. You can use same SQL statements in Spark integration with the Hive. Then what is the difference between SQL statements in Hive, SQL statements, Hive SQL statements in Spark? Whatever the SQL statement we write in Hive, internally converted to MapReduce applications, right? Yes or no? Here, same SQL statements, if we write in Spark SQL, these are converted to uh, Spark queries. So Spark queries are faster than MapReduce application. Spark queries are faster than MapReduce application, right? It uses in-memory computing. Same SQL queries uses in-memory computing. Previous one, SQL queries on Hive uses MapReduce. It uses both disk memory and in-memory for processing. Yes or no? No one is responding. How? Right? See, we imported these two packages. We created Spark context and we created SQL context. Now, no. So here, Prasad, Prasad, question is, we are importing package import warg dot apache dot spark dot underscore. It doesn't import. It does not import sub package classes. Sub package classes. It imports only. It imports only uh, that package classes. That package classes, not sub package classes. You got the point, Prasad? This statement import only classes presented in this package, but not sub package classes. Okay, so that's why we need to import .sql separately. .sql contains separate classes. .spark underscore contains separate classes. Sub packages contain separate classes. So it doesn't mean this highlighted statement doesn't mean it imports all the sub package classes. Okay, it doesn't import sub package classes. It imports only that package classes. Okay, let me give clear clarity. So this is main package, SQL package, Spark package, Spark package. This Spark package contain star dot Scala, means Scala classes, Scala classes, and it contains sub package. Sub package name SQL. Sub package name SQL. This sub package contain again star dot Scala, means Scala classes. So if you import import warg dot apache dot underscore, sorry, spark dot underscore, then it imports only these classes. It imports only these classes, not sub package classes. If you want to sub package, we need to import one more statement. Import org dot apache dot spark dot sql dot underscore. Okay. So if you import main package, it doesn't import to child packages, sub package classes. You got this? You got point, Prasad? Did you understand? Yep. Okay. So in this statement, what I'm doing, importing or loading, CSV file into data frame, CSV file into data frame. Okay, so what I'm doing, loading CSV file into data frame. Let's see this syntax. Val data frame underscore CSV equal to SQLC dot read dot format is CSV dot load and CSV file location cancer data dot CSV. I want to read this data frame and convert in. I want to read this data set and I want to convert into data frame. So SQLC dot read dot format we are passing CSV dot load and we are passing this data set location. Then it will read that data set and converts into data frame. Observe. Next, df underscore CSV dot show and pass 10. If you pass 10, it will read 10 records from that. See, data frame is created. Data frame is created. So if you observe here, underscore C0, comma, underscore C1, comma, like this, it is showing 10 more fields. It means total 12 fields are presented in, in that data set. Let's open this one. Total, how many fields are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 fields are there. So totally 12 fields are there. So it's showing 12 columns. Okay. Let's display this one. df underscore show. Show method. See how to display RDD data. Can anyone tell me? Rameshan will tell how to display RDD data, Rameshan, on console. Rameshan not concentrating. So can anyone tell me? Sir, already we completed Spark core. Why are we asking, sir, again? You are thinking like that, right? Spark core is completed yesterday only. Again, you are asking Spark core questions. Ravi, what is collect function? It will get all data. Yes, perfect. You are 100% correct. So it will read all the columns of, all the rows of, not all columns, all the records of RDD. And is there any alternative method to collect method, Viren? Viren, is there any other method alternative to collect? Yes. Oh, Viren not respond. So we have a take function, right? Take function. In take function, we pass parameter number of records, right? Based on the whatever the value you pass, it reads those many records, right? So we have we have collect and take functions. Same as in data frame, if you want to read data from data frame, we have a show function. For show function, if you pass parameter, it will read only those many records. If you observe here, first column, first row contain column names, right? Hello, are you observing? First column contain, first row contain header. Perfect. First row contain header. But here, if you observe here, first row is treated. First row is also treated as a record, not a header. Headers are taken default names. Headers are taken default names. Default names. I want to resolve this issue. I want to say header is true. Then observe how do we use same data frame only. So here we pass one more option called format sqlc.read.format csv dot option header comma true true dot load. What is this option intimates SQL context is a SQL context. My CSV file contain header. So consider header and read first row as a header and use instead of default column names, use my header column names. So here it uses default column names, right? Then whenever you pass a header equal to true, then it will intimate SQL context, a SQL context, my CSV file contain header. Use that header names for our schema. Okay, then observe same thing. Wow. Previously, if you observe here, what is happening here? Underscore C0, underscore C1, default column names. But here it readed first column name, first row, and first column, second column. Like this, we have 12 columns. Let's execute df underscore csv dot show. So these are column names, and this is the data, right? Yes or no? Then there is one more function called df underscore csv dot print schema. Print schema. What is print schema? Did you execute any describe command in SQL? Did you run describe command in SQL? Right? What is describe command, Ravi? Only Ravi will tell. What is describe command? It displays all column names with the data types, correct, right, Ravi? It displays all column names with all data types. Yes or no? Table structure? No. Column names with the data type. Schema of a table. Yes or no? Schema of table. Right? Same as here. If you execute df underscore csv dot print schema, it also gives same. Observe id column taken as string, name column taken as string, age column taken as string, gender column taken as string, state column taken as string, symptoms taken as string. So every column taken as string. But if you observe really, yep, metadata. Okay, if you observe really, id column contain numeric data, right? Age column contain numeric data, right? Okay, stage column contain numeric data, right? But still, it is taking all columns as string type. Why? Why it is taking all columns as string type? Can anyone guess why it is taking all columns as string type? It is reading first row. First row values are almost all nulls. So it is simply taking all columns as string. But I want to give an indication to my data frame. I want to give indication to SQL context, not data frame. SQL context. A SQL context use corresponding data types, not all columns are string type. Use corresponding data type. Then how do we intimate means there is one more command call here. While creating data frame, here we use dot in dot option infer schema infer schema true infer schema true. What is this statement is it will intimate SQL context. Before read data, don't consider only one column. Read all the columns and based on the all columns assign data type. That is the meaning of infer schema. Otherwise, it will consider all columns as string. If you not pass this option, it considers all columns as string. Let's execute. Okay, let's print schema now. df underscore csv dot print schema. Observe, id is integer, right? Age is integer, right? Stage is string. Why it is considering stage is string means it may contain some string values. So it is assigned corresponding data types, right? It is assigned corresponding data types, right? Yes or no? Okay. Then remaining is same. df underscore csv dot show of 10. Now observe one more time print. id is integer, age is integer. Go here, id is integer, age is integer. There is one more integer here, stage. If you observe stage, let's print instead of 10, let's print 20. Let's print 100. Somewhere it may contain one character. Character may has character. That's why it is considering stage column as here. Observe, right? Normal. Stage contain normal. Because of this normal data, it is considering string column. So Spark is not. Spark is very intelligent. It cannot assign directly its own types or default types. Based on the data presented in columns only, it will assign corresponding data types. But ID column, age column contain numeric values only. That's why it is taken integer. Okay. Yep. So we applied header equal to true. We applied header equal to true. And we applied infer schema equal to true. Infer schema. See, we are passing CSV file, right? So by default, when I say sqlc dot read dot format CSV, it will automatically take delimiter is comma. Delimiter is comma. If CSV file contain any other delimiters, then we can pass that delimiter. We can pass that delimiter. Okay. Otherwise, we pass only same delimiter. So this is one type. And next one, yep, one more data frame I will create. See, this is our workspace, right? So here, Spark SQL we are creating. What I am doing, I have a CSV file. I have a CSV file. 101, comma, Srinivas, comma, Srinivas, comma, next one, 20,000, 20,000, comma, M, comma, 11. So 102, 102, employee name, and salary of employee, gender of employee, department number. Okay. 103, employee name and salary of employee and department number. Next one, 104, employee name, employee gender and department number. Next one, 105, employee name and employee gender and department number. So these are 5 records. Let's save this one. So before that, here we have header, employee number, comma, employee name, comma, employee salary, comma, gender, comma, DEPT, department number. Okay. So let's take here desktop, quality thought, Spark and Scala, batch 3, workspace, Spark SQL. Here I am writing employee dot CSV, employee dot CSV. Okay. Now tell me. So I am creating data frame, right? So data frame 1, data frame 1. So SQLC dot read dot format CSV, option header equal to 2, option infer schema equal to true, load. So it is in same directory. That's why, sorry, what I am doing, employee dot CSV, right? So I am saying employee dot CSV, df1 dot show, it is reading all the records, df1 dot print schema, so we are getting employee number integer type, employee name string, salary integer type, gender string, department number integer type. Is that clear, Prasad? Okay. Next one. Uh, uh, yep. No problem. Yep. Next one. I want to read JSON data. I want to read JSON data. So what I'm doing, I'm writing JSON EMPNO colon 101 comma ename colon Srinivas ename colon Srinivas comma sal colon 20,000 comma gender colon M comma department number colon 11. So this is my first JSON object. Like this, I have two JSON objects or two or more objects. Okay, 102, 102, 102 employee name. So I'm changing different names here. Sal 30,000, gender female, department 11 only. 103, name Badri, and Sal 40,000, gender is male, department is 12. Okay, 104, 104, name is 50,000 and gender is female, department number 12. Next 105, employee name, salary and gender and department number. Okay, so I taken different names. What I'm doing in same location only, what I'm doing, employee dot JSON, employee dot JSON, save this one. Okay, this is JSON object, okay. How to read JSON object in Spark context? How to read JSON object in uh, how to read JSON object and convert into data frame? So here instead of CSV, we use read format is JSON, and no need to use header, no need to use infer schema, no need to use header, no need to use infer schema. If you pass JSON, so JSON object clearly tells if it is in double quotes, it is treated as string. Value is in double quotes, it is treated as string. If value is not in double quotes, then it will treat it as integer. Okay, let's execute that statement. So it's saying corrupt record. It's saying, yep, not a CSV, right? This is JSON. JSON pass JSON employee.json. So it is taken column names, department number big int, employee name big int, three other columns. Okay, df1 dot print schema. So it is printed schema. Okay, next one, df1 dot show. So we got the data, right? Okay, let's same as let's take XML file. XML file contain root tag employee root tag. This root tag contains child tags. Child tag empno. Child tag is empno 101 and empno ename Srinivas, ename Sal, some 20,000 Sal. Next, gender is male. Next one, slash gender. Next one, department number 11 slash department number. So this is my XML file. XML file contains some records. So I have only one record. Like this, you can take multiple records. So let's take two records. Let's take two records. Okay, I have two records. Let's save this one. Employee dot XML. So this is XML file. Okay, open this. Observe. So this is CSV file, JSON file, XML file, XML document. Right? I want to load XML file into data frame. I want to load XML file into data frame. XML file into data frame. Then here data frame 1 dot read dot format XML. Observe what will happen. XML. Then employee dot XML. Let's wait 1 minute. I'll come again. 1 minute. Yep. Are you hearing me right? Hello? Yep. So let's enter command here and observe. So we got error. What is the error we got here is JSON, it is taken by default. CSV, it is taken by default. But XML file, we have to perform some parsing operation. So here we need to add dependency. We need to add that dependency. Let's go here and search XML dependency. XML Spark XML. Okay, it is giving different one. So what I'm doing, Spark XML Maven dependency. So Databricks API. So this is one 2.11. and 2.10. Let's go older version. Let's go this one. Select this SBT. Okay, and update this one. Save this dependency. So it is started importing that package. So processing is completed. Let's execute same statement. So data frame is created, and what it is saying, java dot class not found exception, failed to find data source dot xml. Please find the package. Okay, so this package is not working. Let's search another package. Let's go this one. So this is 0.31. Let's change this dependency. Let's save this one. So it is processing. Once again refresh here. Okay, let's go to SBT cell. Once again import that one. Execute this command. So still it's saying class not found, class not found, failed to import this package. Okay. Mm, let's go here. I have already created one more. Scala version 2.11.1, right? Let's go here. This is Scala 2.11.1, same version only. Scala 2.11.1. This XML version is different. This is Scala 11.12, 2.11. Target is same. Let's go. I have already created one more. Spark workspace, Spark SQL. Let's use this build.sbt, and here mm, 0.41 only. Perfect. I used the same thing, right? But it is working for me in previous application, but it is not working for us now. Let's replace this one. So what I'm doing, let's go to build. Let's refresh once again. Yep, successful. Go to SBT cell and execute this one. Still it is giving error. Mhm. Let's stop this one. Let's start SBT cell. It's taking some processes background. Once it is completed, we'll see. Let's wait to finish that one. Yep, processes are completed. Let's go console. Yep, let's import the packages. Import SQL package. Let's create a Spark context. Let's create SQL context. Let's set warning. Let's import. Let's create SQL context. SQL context. Now uh, create a data frame for XML file. So data frame is successfully created. Data frame is successfully created, but it's showing empty array. Let's display df1 dot show. So array is empty. df1 dot print schema. It's showing just empty. There is no schema. We are passing XML file and format type we are specifying XML type. Then we imported package, but still we are getting empty data. XML is a combination of XML contain parent and child keys, right? Hello, hello, right? So here we have to pass one more option called while loading XML file data. We have to specify one more option called dot option row tag, row tag, and we have to specify what is the row tag. Row tag is employee, right? Yes, employee. Parent tag name we have to specify. That's it. Press enter. This time it is created data frame with some data, right? Let's df1 dot print schema. Okay. Next df1 dot show. We got two records. Yes or no? So we got data, right? So in this way we read data from. In this way we read data from CSV files. We read data from JSON files. We read data from XML files. Do you have any queries in today's class, team? Tomorrow we have class is same time 8 to 10. Tomorrow also we have a class same time. Tomorrow we are going to discuss very good concepts of very important concepts of Spark SQL. First we connect a database. We read a data. So we discuss database integration. Next, we discuss Hive integration with Spark SQL. Hive integration with Spark SQL. After completing that two concept. Tomorrow is Saturday. Sunday also we have same time 8 to 10. After completing RDBMS integration with Spark and Hive integration with Spark, then we see what is dataset, what is Spark session. Then after that we are going to see some other concepts